Appreciate that. Gabe, glad to have you here too. All right, so we're going to continue on with what we were doing last time, which is translations of functions. It's basically taking functions and moving them around. Okay, so we've been using Desmos a lot for this stuff, which is, works out great. So just a quick recap of what we did last time. So we discovered that when you have an absolute value function, you get a V shape. And when you have an x squared function, you get a U shape. And these numbers here, like the +6 and the -3 here, move you up and down. So this was up 6 and this was down 3. Okay, pretty easy stuff, right? Okay, so then we talked about the linear equation here and how we figure those out by starting with the y-intercept. And of course my drawing is terrible, but that's because I lost my pen. So I'm having to do this with my finger. Not good. But anyway, so we start here at 2, and then you do your slope, which is going to be the change in y, which is going up 1, and the change in x is over 3. And that gives you your second point. You just connect the dots. Then we discovered that the shape of the x, the square root of x, is kind of a weird looking little curve. And this one would start at -8. And there's no negative numbers for x because you can't have negatives on the square root. So we'd start down here at -8 and kind of go like this. Okay. And like I said, that was something we looked at on Desmos the other day. And then this guy, we looked at Desmos. I didn't put it on the graph here. When you have a number in with the x, like in here in the parentheses, okay, this is going to move you actually kind of the opposite way that you would think. So when you see x -2, what it does is it actually moves you 2 to the right. So think of it this way. You think to yourself, what number do I put in here to make the parentheses stuff go to 0? Okay, so that'd be 2 - 2. So we find 2 here on our graph. And then we just do our standard kind of parabola thing. And again, this is not looking for perfection here. We're just looking for, if you know the starting point, you know the basic shape of the thing, we're good to go. Okay? All right, so I think that's where we left off. So I think this next guy was the one that was up. So as we discovered in our last exciting episode, we found that the absolute value thing is a V shape, right? So x squareds are u's, and the absolute values are v's, okay? So this is very similar. So you remember the square root, not the square root, excuse me, the absolute value of v, just v on its own, looked like this, right? Just kind of did one of these numbers, right? Remember that? Okay. So what do you think is going to happen here? So again, this is another situation where it's kind of in with the x, right? So over here we had a -2, we went to the right 2. Over here we have a +4. So what do you think is going to happen there? What's going to happen with that one? So -2, we went 2 to the right. What do you think is going to happen with this guy? Yeah, we're going to go 4 to the left. Perfect. So instead of being at 0, 0, we're going to come over here to -4, and that's still going to be the same basic shape, like that. Okay? And maybe we should break out the des here. Just so we can look at it. All right, let's bring in des real quick. All right, so what we had discovered was if we did absolute value of x, and that's a slash, I know. Value of x, we get that guy. And then our new guy was absolute value of x plus 4. There we go. So as predicted with our original function, we bottom out here at 0, 0, and it goes up from there. And with our new guy, he bottoms out at minus 4, 0, because if you put minus 4 in here, minus 4 and plus 4 is 0, the absolute value of 0 is 0, right? And then since it has to be a 0 or a positive number, we're just going to go up from there in either direction. Okay? Questions? Thank you, Chloe. All right, let's go ahead and pop Des out of here for a second. I'm sure he'll make his triumphant return here at some point. So let's see what else we've got here. Okay, so now we've got a square root again, right? So we know what the square root looks like. In fact, let me bring Des back in. We'll pull that up real quick. Okay, so let's just do square root this time. So we get the square root of x. Drop him out so we can see. So again, we get sort of this weird little curve here, right? And it will keep gradually going up. It just doesn't go up very fast. And we've also noticed that there's nothing going on over here because you can't use a negative value for x. It has to start at 0 and go up. So it starts at 0 and goes up. And y goes up, but just not very fast. Okay. So that's your basic setup. Now again, notice that this is under the square root, so we've got something in with the x again. So really all you're looking for with these guys is you're kind of looking for a starting point. Okay? So again, if we have plus 3, how's that going to move our graph? Yeah, it goes the opposite way we think. We see plus 3, that means we're going to go to the left 3. So that's going to make our starting point over here at negative 3, and then we're going to kind of get that same shape. Okay? So again, so if we bring Des back in here for a sec, and we say, okay, well, what's this guy look like? So we go to our square root, and we're going to do x 3. Move over here a little bit. So this moves us over. Let's get rid of this guy. This moves us over and starts at negative 3. Why does it start at negative 3? Well, again, if you pop negative 3 in here, negative 3 plus 3 is 0. The square root of 0 is 0. That's fine. So since we have this extra 3 added in here, we can actually go all the way down to negative 3 before we have a problem with the square root thing being negative, right? Because if you pop over here to 4, so if you had minus 4 plus 3, that'd be the square root of negative 1. Thanks for playing, right? It's not going to work. So that's why it starts here. So really, when you move this thing around, it's like a starting point for this. Okay? So you're going to have the same basic shape. What we're looking for is that starting point. So your basic graph is going to start at 0, 0. This guy, since we moved him back, he's going to start here. Make sense? All right. So let's go back to what we were doing. Cool. All right, so this one is a cube root and x minus 5. Okay, so let's just talk about the minus 5. Which way is this graph going to move? This one's going to go 5 to the right. Good, Chloe. I'd say you got that part down. Nice. Now, the question is, can you take the cube root of a negative number? Now, cube root means we're going to have the same number multiplied 3 times in a row to give us the thing underneath the cube root sign. So can you take like the cube root of, say, -8? Could you do that? What do you think? Yeah, you actually can. So square roots or any even power, like a square root, a fourth root, a sixth root, no negatives. But odd number powers, like a cube root, a fifth root, things like that, yeah, you can. Because here's why. If you multiply -2 times -2, we get +4. But then if you multiply by -2 one more time, you get 4, +4 times -2 is -8. So the cube root of -8 is -2. So here's what the graph looks like. Let's bring our good friend Des back in here. All right, let's pop these guys out of here. All right, so I'm trying to remember if there's a cube root thing on here or not. There's got to be. Let's see. So I might have to use the 1/3 power. Let me see here. Now, here we go. All right, so put that in here. So this is going to be a cube root. And then we put x here. And we'll see what happens. Huh. So what we kind of get is, notice this looks like the square root, right? It's kind of doing what we'd expect for the square root. Then over here, it looks like the square root kind of turned upside down, doesn't it? Let's just bring him over a little bit. So what we're looking for here is this point where it kind of makes the turn, okay? And the higher up math guys, like the calculus guys, they have a name for this. They call it a point of inflection. Ooh, fancy schmancy, right? So yeah, the calculus guys really try to make themselves feel important. Just saying. All right. So then with our particular problem, we had, what did we have though? Remember, hang on. We had -5. Yeah, very. Like you wouldn't believe. Okay. So then we said, all right, well, we got a problem here. And we had +5. So we said, well, that was going to move us, oh no, -5, excuse me. That was going to move us over to the right. So let's do it. 5. Look what happened. Now our little point of inflection, is now at 5, 0, as opposed to being here at 0, 0. So again, it just moved us over 5, but it has the same basic shape, as you can see. Okay? So yeah, key point with that one is that you can take the cube root of a negative number. Square root's not so much. Okay? So yeah, good job on that one, Chloe, that you understood that that was going to be how it was. Okay, so that's our guy. So again, we'll go back to my rather terrible drawing here. So we're at 5, so it's going to kind of go like that and kind of go like that. Okay? So that's our basic setup. Questions? So the biggest thing I'm hoping you're taking out of this is that graphs aren't nearly as scary as everybody wants to think they are. I don't know where that came along, but at some point everybody's like, ooh, graphs, scary. We don't like them. They're really not that bad. All right, let's check out another one. Okay, so this one says, each graph is a translation of the given function, right? The function of the graph. Okay. So here's our original, right? This is our parent function, as they call it. F of x equals x squared. So basically what we're looking for is, where does this thing bottom out at, right? So this particular graph bottoms out right here, okay? So what point is that? Well, that is x equals 1 and y equals 0, right? Okay, so we moved 1 to the right, okay? So this will be f of x equals So this is going to be something squared, right? And it's positive, so no negative sign out front. And then since we moved to the right one, we kind of put in the opposite here. So that's positive 1. We're going to throw in negative 1. And that's our guy. Make sense? So we see the U shape and we go, x squared. Plus they tell us it's x squared. And then we say, okay, so if we go right 1, that means we have to kind of put the opposite number in here, which is minus 1. Okay. Cool. Let's check out another one here. Okay, so this one right away we look at and we go, well, okay, that's a cube root, right? And then again, they're nice enough to tell us that. Let's say f of x is the cube root of x. All right, so how did we move this time? So this time it looks like they're going by 2's here, so 2, 4. Looks like this would be at minus 6 for x and still for 0 for y. So again, we'd write this up. Okay, so we say f of x equals cube root, so you got to put a little 3 here. Okay. Of x, and then what's our number that goes under here? Nailed it. Good job, Chloe. So the cube root of x plus 6. There's our boy. Fabulous. So when you have a number inside of parentheses, underneath the square root, inside of an absolute value, that's when we move left or right. And we go the opposite way, right? Okay. Good. Good. Let's check out another one. All right, so this guy, absolute value, right? Like I said, even if they didn't tell us that, we see the V shape, we go, absolute value, okay? And again, same deal. So we have moved, it looks like 10 to the left. All right. So that's right here. So that means that our point there is going to be minus 10, and again, 0. All right. So what's this guy going to look like? So we're going to have f of x, and that's going to be the absolute value of x. Okay, Chloe, you're in here twice. Not sure what that's all about. So again, since this is negative 10, we're just going to switch the sign, make this positive 10. I need a little more room, so I'm going to do that. Now you're only here once. Got some weirdness going on your side? All right. So again, we went 10 to the left, so we're just going to switch the sign, put that up there at the absolute value. It's all good. All right, let's continue on. So this guy, square root of x, right? And like I said, we'd have known that just by the shape. And where's he starting at? So again, we're looking for that starting point. So it looks like, again, this graph is going, each block goes by 2. And we're partway in between this one. So I'm thinking this is at 5, 0. So that's going to be our point right there. Okay. So then we do the same thing. We say, okay, so this is going to be an f of x. It's going to be some version of a square root. And we got x. And what number do we need to put in here? So what number goes under here? Perfect. Minus 5. Outstanding. Okay, so again, just kind of switch the sign to the starting point, put it underneath the square root, bam. There we go. Awesome. All right, let's check out a few more. We'll call it a day. Oh, now here's some weirdness. We haven't seen one like this yet, have we? Wow, they kind of went from 0 to 100, didn't they? Okay, so let's talk about this. So here's what this first guy's going to look like. Yeah, right? Let's look at 2 to the x on Desmos. Let's do that. Okay, so let's clear this guy out. Come on, there we go. So we'll go 2, and then raised to the x power. Okay, so this is an exponential function, which just means that every time the exponent increases, we keep multiplying by 2. So notice here at 0, we're at 1 because 2 to the 0 power is just 1. Then if we come over here to 1, 2 to the first is 2. And if we come to 2, 2 to the second is 4. So we're just multiplying by 2. So it's going to be 1, 2, 4, 8, 16, blah, blah, blah. Okay, so let's go back to our other guy for a sec. Let's talk about this guy first. What does this guy do? Yeah, let's change colors. Why not? What does this guy do? How does that move our graph? When we just tack a number on the end, what's going to happen there? No, that's when it's in with something. This is just a number on the end. Remember, we kind of started off with these. So this is basically saying whatever value I get here for g of x, which is a fancy version of y, we're going to subtract 7 from us. How's that move our graph? Yeah, we haven't talked about that yet today. So it's not left and right, so what's it doing? Yeah, there we go. So that's going to go 7 down, right? Now, once again, let's look at this guy. So we've got x plus 4. So we have a number in with the x as part of the exponent, right? So how's that going to move? It's plus 4. So how's that guy going to move? So this guy was down 7, right? What's this guy going to do? Yeah, left 4. Perfect. So we're going to go that way, 4. Okay? So you saw that basic shape. Well, now it's going to be, instead of being at 1, 0, right, it's going to have to drop down. So we're going to drop down here to minus 6, and then we're going to go back 4. So minus 6 and 4 would be right about here. And then it's going to still do that same shape. But it'll look better on Desmos. Let's do that. All right, so here's the Des. So let's see, can we put this guy in here? There we go. So we're going to go x. Let's move him over here a little bit so we can see. All right, so we're going to go x plus 4. Oops, that plus 4 came out front. I was trying to get it with this guy. Let's do it this way then. Let's do x plus. Do I need a parenthesis maybe? Let's try that. X plus, there we go, 4. Okay. So that moved us back 4, right? So you can see that right here. So instead of being at 1, 0, or excuse me, instead of being at 0, 1, we're now at minus 4, 1. Because if you put in minus 4 here, minus 4 and plus 4 is 0. 2 to the 0 power is 1. So that's why you're right there at minus 4, 0, if I can get it to do it. It was off a little bit. Well, you get the idea. Almost had it. There it is. Well, there it was. Okay, and then the other thing that happens is we're going to move down 7 because we're going to do minus. Wow. Okay, so let's come down here. So as predicted, here we are at -4, and since we dropped down 7, but we were already at +1, right? Then we're going to have this guy here. Oops. Try it again. There it is. So -4, 6 for a brief second. So as you can see, you could trace along this line just by moving the arrow. But it's kind of hard to hit that spot sometimes. There we go. So 4, 6. Okay, and just for the heck of it, let's go ahead and put up the original function here. So that was 2 to the x. So there's our original guy. So again, he went from being crossing here at 1, 0, then it moved us back 4 and down 7, right? So we went back 4 and down 7, and that's right here. Ooh, nailed it. Okay. There, so we can see a little better. So again, if you put in a number with the x, and I guess the parenthesis kind of drives that point home here since I had to do it that way. So this moved us back 4 and down 7. Cool. All right. And there's my lane version of it. So then this guy, this is going to be an absolute value, right? Now, in order to figure out where this, because it's going to be a V shape, right? Absolute value is a V shape. So to figure out where this is going to be, and I'll never get this plotted very well, but we'll go to Des in a minute here. To figure out where that bottom point is, all you have to do is switch the sign on this guy. So make him -4.3 and leave this guy alone, -2.7. So back 4.3 down 2.7, that's in here somewhere, like that. But again, we'll break out Des for that one. Okay, so again, let's start with our absolute value of x. There's that guy. Get rid of this guy. And then our new guy is absolute value of x. It was plus 4.3, right? 3. So you can see it. And then on the outside, we had minus 0.7. You can see how it moved down. So in our original guy, our bottom point was 0, 0. Then we said, okay, so we switch the sign on this guy, make him -4.3, leave this guy alone. And when we do that, look where we're at. -4.3 and -2.7. So we went back 4.3, we went down 2.7, and it's going to just go straight up from there. All right. Questions? And again, you can Google Desmos, and you can mess around with Desmos on your own if you'd like. You can make some pretty cool patterns on it, by the way. Especially if you get into, there's a thing called polar coordinates. That does some pretty cool stuff. Maybe we'll mess around with that sometime just for laughs. All right, so we good? All right, so there's my lane version of it again. All right. So this one says select all statements about the graph f of x equals x minus 2 quantity squared minus 3. Does the parabola open upwards? What do you think? Yes, check. Problems downward, can't upward and downward both, right? So the vertex, we switch the sign on the first guy, leave the second guy alone. So is the vertex 2, -3? Yep. Check. So obviously it can't be this guy, and it can't be this guy. Well, that was easy. That wasn't bad at all, was it? Cool. All right, one more and we'll call it. Actually, looks like we're going to get done a little bit early today. So it says, how is the function the square root of x translated to obtain the graph of x plus 5 under the square root and then plus 6 outside the square root? So which one of these is right? This is a total ACT question. ACT has 5 possible answers. So which way is this guy going? So you're saying C? Okay. So C is left 5. So that's the opposite of this. Good. Up 6. Perfect. Nice job, Chloe. Okay. Any questions? All right. That's because Chloe's kicking butt and taking names, right? Good job. All right. Well, that's all I got for today. So again, I thank you guys for showing up, and we'll try some new stuff tomorrow.